in his 25 years at Environment and 11 years at York University with a PhD from the University of Guelph. He's known across the watershed. He is probably one of the most popular speakers we have ever engaged. He is an engaging speaker. Somebody indicated tonight they can't get enough of him. They love to hear about the spiny waterflea, and that's exactly what he's going to talk about tonight. So, without any further ado, let's have it.
Well, the first thing I want to say is the greatest pleasure for a teacher is to see their students excel. So, Jim did his PhD in my lab, and I just want to acknowledge the excellence of his work. So, thanks, Jim. Unfortunately, the other person who couldn't come is also a student in my lab, so I was really looking forward to saying things about both of them, but I'll restrict that. I have talked a lot in the area. I love this area. My wife Sandy and I have lived here for almost 30 years. And one of the areas that I've worked on is the spiny waterflea. I thought I'd introduce it with this remarkable 160-year-old painting of the spiny waterflea done by a brilliant Norwegian biologist, a classic biologist in Darwin's day, who had mud sent to him from all around the world off the Beagle and other ships, the great naturalist expeditions of the 1800s. He sat in his comfortable office with an ancient microscope. People sent him mud from the bottoms of ponds from around the world. He added water from Norwegian lakes and hatched them out, and he ended up describing about 60 species of water fleas. I'm going to come back to this, and his paintings are admired around the world. They were lost they were lost for almost a century, and then rediscovered when there was a flood in the basement of the Rare Book Library, the Rare Book section at the University of Oslo's library. All these wonderful old paintings reemerged. And so I use them whenever I can, because first of all, their accuracy is astonishing from what I've seen in the animals. And so I'm going to, if you don't see this picture, ask me to turn around. And so I wore my spiny waterflea shirt for all to see. Why are we talking about the spiny waterflea? There are a couple of reasons. All the red dots, this is a slide from the Ontario Federation of Anglers and Hunters Invading Species Awareness Program. I think a guy called John Zoltak produced this one. All the sort of reddish dots that you have trouble seeing versus the greenish dots. Why they used green on green is beyond me. And I know Neil can't see any of this because it's all red-green. And but all these, Neil, whatever these dots are that you see, whatever the color that is to you, these are invaded lakes, invaded by the spiny waterflea. And if you look across Ontario, you see that Muskoka is kind of ground zero for the movement of the spiny waterflea out of the Great Lakes and into inland waters. And that's absolutely the case. And so since they came out of the Great Lakes in the late 1980s, we've kind of been following them at Dorset. So let me go back and introduce you to the spiny waterflea. It's a little animal about ½ an inch long. And you can tell a lot by looking at it. This animal that SARS painted was collected in the spring. I can tell it was collected in the spring because this long tail spine that gives it its name is straight. There's no kink in it. I can also tell that the distance between these spines is very close. That only happens in the spring. I can also tell because this lady is carrying 5 mature eggs on her back. In the summer, they tend to have about 2 eggs. They produce 2 bigger eggs so that the animals are born in a larger size and can outgrow fish predation. But in the spring, they just want to get the population going, so they produce a larger number of small eggs that produce small babies. And we only get this many eggs in the spring. So 160 years ago, when SARS was doing this painting, they collected this animal in the spring. This animal, these are crustacea. So like Jim's crayfish, and like lobsters, they have a shell that they shed. The spiny waterflea is unique that it doesn't shed its whole shell, and it can selectively soften. SARS amazingly saw the shell selectively softening right here. This is about to peel back, because within about 12 hours, all these 5 babies are going to emerge. These are visual predators. About 1/3 of the volume of the whole head is an eye. And so think of each of us having an eye the size of 1/3 of our head. It would be pretty scary. So these animals see better than us. They can see in the ultraviolet. They're actively hunting visual predators. And that big black eye is the sign of that. There's a downside to the big black eye. You can't hide black. Fish see that eye. And so if you want to see across the whole visual waveband, you have to have a black eye, and then everyone will see you. I think that's the arrow that just came in. First thing, you have to see the prey, but then you have to catch it. So they swim with these enormous second antennae that paddle their way through the water. Now an animal that's this size, the viscosity of the water feels a bit like honey. So imagine trying to push through honey in the water, because there's a relationship between the size of an animal and the viscosity of the water. This is really like swimming through honey for an animal of that size. So they need a weapon. They've got a big black eye that all the fish see. And so the weapon they have is this tail spine that's sharp as a straight pin. If you take a handful of them and chew on it, it's like chewing on pins. I've only done it once. And so I know what fish would feel. And it's like being stabbed by pins. But it's a good trick. So if I was the spiny waterflea, it's like dragging a 20-foot 2x4 along behind me. And so that has to work, or you're not going to drag that darn 20-foot 2x4 around behind you all the time. And so most fish are gape-limited predators. They don't take a chunk out of things. They want to take in the whole animal. And so having a 20-foot 2x4, if all terrestrial predators did that, would be a good trick. There would be no predator on Earth that could eat us. So it's a good trick. Fish have to be 20 times its core body length before they can eat it. So having that spine is a good trick. They do other things. You can't see this very well, but the legs are bright blue. So if you've got a weapon, it helps if the enemy can see the weapon. So they train fish, just like monarch butterflies train blue jays, that they're colored, we taste terrible, don't eat us. The spiny waterflea has bright blue legs. It often has a red tail spine. It's the only thing that drags a red stripe through the water. You can't see it in this old painting. It's the only thing he got wrong. But I'll show you a picture of it in a minute. And the goal is to eat. So that thing right there is a mandible that's half the size of the head. It would be, think about a big tooth that's about this long coming out of me. So they pierce and suck with that big mandible right there. And the last thing about this painting that astounds me and tells me what SARS was doing 150 years ago is the color of the food in the digestive tract. You can't see it very well here, but it's jet black. He's painted this digestive tract as jet black. There's only one thing in the water column that the spiny waterflea could have eaten that's jet black, and it's the visual pigments of other spiny waterfleas. These animals are cannibals, and so what SARS must have done is have a bunch of spiny waterfleas in the lab, and then he painted the lone survivor. And so we've seen that years later in our lab. We see exactly that. We can't keep them together in the lab. They just eat each other. And so my summary of what we learned from this forensic artistry of this 150-year-old painting is that that's all true, is that it's a large, actively hunting, visually cued, brightly colored, cyclic parthenogen. We haven't talked about that. Every 10 days, a female will produce another clutch of eggs like this at 20 degrees. It's a daytime predator, so it's actively swimming in the water column during the day. Eating anything it can catch, and it's a cannibal. It's protected by this long, rigid tail, protects it from small fish. It's very fecund, maturing in 10 days, growing almost as rapidly as its prey. If the lions grew as fast as the rabbits, there would be no rabbits. And so this is an animal that grows as fast as its prey. So given these traits that we can see from this marvelous 150-year-old painting, we shouldn't be surprised that there are changes happening when this invader arrives. So, jump ahead 150 years. We collected this animal, spiny waterflea, in Harp Lake in 1996. Bill O'Neill was a photographer, he wasn't a photographer, he was a computer jock in the lab at the time. Loved taking photographs. He took this photograph of an animal halfway around the world from where it's supposed to be. 5 eggs in its brood pouch, just like this old painting. We collected this animal in the spring. If we had the lights down, you'd see that the tail is bright red. That's why. That's the only thing that we didn't see in the SARS painting. This is a millimeter ruler, so this animal is about a centimeter long, half an inch long from head to tail. Okay. Why do we care about non-Indigenous species? There's really only 4 categories of threats to the lichen legs. All the thousands of kinds of threats, you can group them in 4. We can affect the lichen legs, indirectly affect their birth and death rates by messing with their habitat. We can affect the chemistry of the habitat by polluting it. Jim talked about that. We can affect the physics of the habitat in various ways, but the one, climatic warming, is the one that people are most familiar with now. And these things will kind of affect animals by affecting their birth or their death rates. But we can intervene directly with living communities by harvesting them. In Sweden, everyone eats crayfish. If this was Sweden, that where Jim was giving this talk, the third thing he would have had to talk about is the invading Swedes that were catching and eating all the crayfish. Or we can fiddle with a mix of species. That's kind of the fourth category of these large threats to the lake and lakes. So now, there's 180 non-native species in the Great Lakes. There's 300 non-native species in Chesapeake Bay. There's apparently only about 30 non-native species in all of Sweden. But and in Muskoka, what would you say, Jim? I don't know, in lakes, 10 or something? Maybe not even that.
Not even that.
Not very many. And we don't have to be concerned about all of them. We should be concerned when something spreads rapidly, has the capacity to change communities in ways that we don't like. We would then define that change as damage. And when it becomes abundant enough to actually cause this damage. One invader in Muskoka Lakes that everyone loves is the invading jellyfish. How many of you have seen the jellyfish in our lakes? Anyone seen the jellyfish? No more hands. If you see a jellyfish, well done. We really have a jellyfish. It's about the size of a loony. I've seen them in Gravenhurst Bay, right beside the Seguin in the water. It's about this big. If you see something in the water that looks like a jellyfish, and you say to your partner, it is. It's a jellyfish that should not be here, and it's spread very rapidly all over North America, but it doesn't seem to do anything bad. So whenever it shows up, we're happy. Isn't that cool to have a jellyfish? But my objectives are to prove to you that the spiny waterflea, which I might call Bythotrephes, is not like that jellyfish. It's spreading rapidly, it's causing damage, and then we'll see if we can do anything about it. So is it spreading rapidly? The answer is yes. We'll jump to the end. Here is our wonderful watershed with a boring name of 2EB in the old M&R books. 1,628 lakes, larger than a hectare. I think it's 12% of the watershed is water. Boy, are we blessed. We're right here somewhere. In 2005 and 2006, with the help of 9 young women and 1 guy, we sampled 311 of these lakes, and here's the 311 lakes we sampled. I won't count them all, but there are 311 lakes there. And there's 100 lakes in each of 3 categories. We stratified by the size of lakes and sampled in 3 size categories. Split all the lakes into all the sizes, and then randomly selected, 30 in this size, 30 in that size. We looked at lakes in strings. There's a little string of lakes that were connected to lakes that were known to be invaded. And then the tricky one, we thought that people were spreading the invaders, so there was this idea of propagule pressure. The number of introduction events and the size of those introduction events, multiply those 2 together, you get kind of a propagule pressure estimate. No one can estimate that. But if people are doing it, then the more access there is from people to a lake, the more the probability that there will be propagules. So what we did is we overlaid a road GIS over all the lakes in the watershed, and then chose lakes that were different distances by road to known invaded lakes and to known cities. And we even interviewed some young fishermen and some old out of shape fishermen, and asked how far they'd be willing to bushwhack, if there was no roads to get to a lake that had great fish. It was Joe, we interviewed Joe. And he's in much better shape now. And so you can't see this, here's the people that did that work. Allegra Label Turkish is in charge. I'll thank the District of Muskoka, because one of these crews was based in the Bracebridge office. The Ministry of the Environment gave us access to planes, so they flew us to remote areas, but mainly we did a lot of pushing of canoes through the woods and through wetlands to get out on a lake so that we could drag this net through the water at 6 stations and see if the spiny waterflea was there. And then every once in a while, if there was food involved, I would go.